everyone. We are very pleased to be here today, and hi to the people online. So today we will talk about our experience about moving to Go microservices architecture. My name is Donia Chaiehloudj. I'm a Go backend engineer at Powder, which is a startup building PC and mobile app for gamers to create content easily. I'm also involved in tech communities. I run the Google developer group at Sofia Antipolis in the south of France, and also involved in women in tech communities. You can find me on social media as Donia CLD, and I would love to connect with you.
Hi, I'm Aliénor Latour, also from France, currently based in Berlin. I work for HelloFresh as a backend, and basically I do Go.
Aliénor and I met in 2018 while working for a company building software for processing satellite images. Basically, they wanted to move from an old solution that was installed across the globe on clients' bare metal platforms to a modern one, like a catalog for satellite images on demand, which was a great challenge. So they made a proof of concept in 2016, so 2 years before. And the goal was to move from a PHP backend, pretty old, to a Go backend with Docker, Kubernetes, and all the cool kits of the cloud. So this proof of concept was accepted, and 1 year later, the industrialization of the product began. But we had many constraints regarding time, quality, resources, because we had a launch date for a pair of satellites in the satellite calendar. And you can see here the image from 2020 from the first satellite, Pléiades Neo. Here are 10 takeaways that I'm going to talk. So we had a blast during this experience, but we will mainly focus on the things that we would do differently. So the first one is about Go. So back again in 2016, not so many people adopted yet Go in the industry, and especially in the satellite world. It was a bold choice during the proof of concept to try Go, but we realized afterward how fruitful it was. In fact, as developers, after the Go tour, the tutorial of Go, you could understand like the syntax, you could understand the Go philosophy, and after 1 week, you can be productive, take a task, and work on the code base. So we might admit that we put Go in the title mainly because we were convinced by the technology. It was easy to learn, easy to maintain. It's designed for web problems at the beginning for Google, and it was adapted to our catalog for the satellite images on demand. And we also had the thing with C++ image processing algorithm, and we could use the feature of Go Go and call C programs in our Go programs. So basically, we love Go now. When we began our project, at the time, we began with baby steps, like any project, I guess, with one microservice moving with 1 or 2 endpoints. But regarding the time constraint, we were pushed to deliver a first viable product that was not so minimal. So we kept piling up features in one microservice. One so-called microservice with almost like 40 endpoints at the end, and it was a huge code base to maintain. So today, I can recognize the symptoms at an early stage of a product going into that direction. And I can say that today we have this in my current work, and I'm struggling to just deviating of it. It's always difficult to find the right balance, but I can say today it's more expensive to extract code from an existing microservice to a new one than creating a new one directly. The architects of the project at the time decided to separate data from processing components because we were doing a lot of data with a lot of satellite images, but processing them was also very costly. And what we did, and we chose, it was a strategy, it was to create one nanoservice wrapping each C function from the C++ algorithm that I just mentioned. But it made the number grow exponentially. So we ended with almost 80 microservices for 20 devs, and it was a huge code base to maintain. So again, it's difficult to find the right balance. And it's always about trade-off. But today I can say that it's now something that I can spot and I can work on it, and I'm more vigilant and talking to the product and to the planning people just to make sure we are going in the right direction at this point. When you begin a project, most of the time you don't always have access to experts and business people. As a developer, you're beginning something, you have like tasks and stuff, and it's what happened to us. So we used unclear keywords in our code base and realized afterward that we were not talking about the same thing. For example, we had the word sensor. I don't know what you're thinking about it when you think about sensor, but in our context as developers, it was an image that was showing the Earth. So any image that was about Earth, like you saw at the beginning. But for business and algorithm people, it was like non-processed images before they were transforming the algorithm. So it just led to misunderstandings. And even in the code base, in the database. And we used these keywords like forever, we couldn't change them afterwards. So that's very important to define the right words. What we tried afterward is to create a glossary. You can say it's pretty basic, but it actually helped us to just define the good words and what they were meaning, so we are all aligned on them, which make a lot of sense when you're coding actually as a developer. So define the word your team should work is very important. And today it's a reflex for me when I'm working at Powder. If I talk with content people, business people, with my team, I try to really define the word within the bounded context. That's a hard topic. When we started the project, we didn't set up the automated deployment, and we actually never achieved it. So even we tried hard, but you have constraint of time, of resources. It was not the priority, not in the planning. So especially about the quality, it was a really hard topic. When you're talking about satellite images, it's very critical that they are well located, for example, and the color imagery also. So we had someone that was verifying manually all the images when we wanted to go in production. So it took it can take 6 months to have a version live in production. Yes, I can see your eyes, yes. So, and we had downtime during 3 to 4 hours because we had many database schema migration and we had millions of images in database. So today we see it as mandatory, Aliénor and I. We suffered from it, I would say, and it's a very important topic for us. Today at current work, we have it, and I'm not sure I'm going to move to a company that does not have a staging reference platform and a continuous deployment.
Hello. In any company, on any project, it's often very hard to finish all of the background work. Everything that looks non-functional, that does not obviously serve the user. It's hard to get it into the plannings. So this microservice of 40 endpoints was when I became the tech lead on that team, was my first battle. So we defined a target architecture. We decided we created all the tickets, estimations, and everything, and then it was only a question of putting it into the planning. But because of all of the time constraints, it took us a little under 2 years to split that service. It's a long time. We had another example where we had different methods between teams of testing and of CI, and we wanted to unify this so that people could benefit from the unification. And each team went in their own direction. We tried different things, and I'm not sure we finished any of them. So what I would do now with the experience would be define from the start what you're trying to aim for, what are the numbers you want to reach, and then start on one technology, check that it fits, and if it doesn't, move to the next one. Because don't start in every direction. there's a saying in French Canadian that says pelleter la neige en avant, which means pushing the snow forward. And sometimes when we take shortcuts in software development, you're just piling up the work for later. So one of the most painful examples that I have in mind is we had a set of C libraries that were deprecated. We wanted to move to the next version. And that never managed to be a high enough priority for long months. Until there was a tiny bug that blocked pushing to production, and that bug required the new version. So that pushed to production to 3 weeks more because we had to migrate everything to the new version. That was already a few months old. What I take from this is, in software, we all know, but we tend to forget that there's a lot of housekeeping that needs to be going on just for the hygiene of your code. Maintaining old versions is hard, so you need to move to the next ones. Refactoring, because you learn along the way. Give yourself time for this as much as you can. We had, as developers, very little knowledge of what went on in production. We had a platform team responsible for deploying. We had no access to production, mostly because of security reasons. Some of the images were classified, reserved for military at first. And so our platform team set up perfect monitoring dashboards for the health of the platform, but there was no business monitoring. As a developer, I would have loved to add, for example, during the development of a processing, I know that if I'm missing one metadata, I can't go on with the processing. So I would like to have a monitoring of how many images per day are failing because of this specific error. And we had no way of adding this into the monitoring. So my takeaway from this is use everyone's knowledge when setting up your monitoring. Everyone, including the business and the product people. You can, if you involve everyone in this, then you can trust your system and prevent incidents before they fall on your head. We had teams for algorithms that were writing C++. We had cloud teams that we were a part of, and we had this platform and user support teams. And these teams were working well, but not communicating so much. And sometimes some subjects required everyone's knowledge. We had one example that we call the rate limiters. So when does a pod need to stop accepting requests, and when do we need to pop up new instances? And that required knowledge by the business, because you need to know what's the typical size of an image, and that depends on the satellite itself. We were supporting different types of satellites. You need to have algorithmic knowledge, because you need to know how many layers of image you need for your computation. Sometimes you will triple the RAM because you need 3 images. And you need deployment knowledge. You need to optimize your HPA and have a knowledge about Kubernetes and how that works. So what we tried to do, but I left before it worked, was create teams with multidiscipline knowledge, so that you have someone in the same team who knows all of these specific things, and you are, as a team, responsible for everything from start to testing and production and monitoring all the way through. In other words, you make it, you run it, and then you can love it. Thank you for your attention. We would like to talk to you outside about your own experience of moving to cloud.
It seems pretty obvious. It seems pretty obvious what we said, but actually it's not the case everywhere. I don't know where you work, but if you're working like with a lot of security constraint and quality, it can be very harsh. So just like would love to know where you're working and how it works there.
Thank you. How you're dealing with this.
Yeah.
Thank you.